Hi, Assalamualaikum warahmatullahi wabarakatuh. Right, in this video, we will learn on how to solve the trigonometric equations. But before that, let's just recall the quadratic equations. All right, suppose we have, like, for example, x squared minus 5x plus 6, which is equal to 0. All right, to solve this one, all right, so of course we have to factorize that expression to be x minus 3 x minus 2, which is equal to 0. And then right, so we have x minus 3, which is equal to 0, and x minus 2, which is equal to 0. So we'll have x, which is actually equal to 3, and x, which is equal to 2. But when this variable x is changed into m, so now we'll have that in terms of m. So we'll have m minus 3, m minus 2, which is actually equal to 0. Therefore, we'll have m which is equal to 3, and another one which is m equal to 2. But when it comes to this sign, all right, so students will have a lot of problems here, right? So because they can't solve, if they can't even solve this one, all right? So basically, let's just let m, which is equal to sine of x. When we let m, which is sine of x, therefore we'll have m squared minus 5m plus 6, which is equal to 0, which is actually similar to this one. And then we'll have to solve this one as, all right, we factorize m minus 3, m minus 2. Therefore, we'll get 0. Therefore, m which is equal to 3, m which is equal to 2. And then we have to change back m, which is equal to sine of x. So in this case, sine of x, which is equal to 3, and sine of x, which is also equal to 2. And then we have to solve for the value of x. In this case, x is undefined, because for the sine, we just have the sine of x, the highest value is 1, and the smallest value is -1. But we can't solve for 3 and 2 in this case, so we don't have solution. Because this is just an example to illustrate how the trigonometric equations very much related to the quadratic equations. Right, in the next section, the next thing that you have to know for the trigonometric equations, so you just need to recall the acousticity. Right. So for the first quadrant, so all is positive. For the second quadrant, only sine is positive. For the third quadrant, only tangent is positive, and the fourth quadrant, only cos is positive. And you should know about the basic angle, right? So the basic angle is somewhere around here. For the second quadrant, the basic angle is, all right, the basic angle for the second quadrant, which is here. For the third quadrant, the basic angle is actually there, and the basic angle for the fourth quadrant is actually there. Sometimes we call it as a basic angle, but some books may call it as a reference angle, right? A reference angle. So both of them are okay. All right. So let's just try to solve one trigonometric equations, all right? Right. So let's look at this example. Suppose we have this one. So what you should do is actually to try to bring this cos of x to the left side. Therefore, when we bring that cos of x to the left side, we'll have sine cos of x minus cos of x, which is actually equal to 0. All right, now we try to factorize the cos of x, because both of these terms, they have cos of x. Therefore, we can actually factorize cos of x. So leaving only 4 sine of x minus, since cos of x has been factorized here, so of course we are left with -1 there. Right, so this is actually equal to 0. All right, so let's just recall to the concept of the algebra. Suppose we have like a dot b, which is equal to 0. So we can say that it's either a, which is equal to 0, or b equal to 0. All right, they can be both, but only one of them need to be 0, so that this side will be 0. So of course, in this case, when we have cos of x as one term, so this one will be, is either this one or 0, or the second part, which is 0. So we can say that cos of x, which is actually equal to 0, and then 4 sine of x minus 1, which is actually equal to 0. All right, so solving this one, all right, so let's just recall the graph for the, what do we call? All right, so solving for cos, if it is 1, 0, -1, all right, so you just need to recall this, what do we call? The graph for the cos, so it will be something like this. All right. Is it that one? It's something like this. Yes. And here should be 2 pi or 360, right? So here should be 180 degrees. So where is the value for the cos, which is actually equal to 0? So of course it's here and also here. So the answer for this one, the solution for this one, for the value of x for making cos of x, which is actually equal to 0, is actually 90 degrees and also 270 degrees. So I've got two solutions here, 270 degrees. Let's check, is it within the range requested by the questions? Yes, of course, it is within 0 and 260. So that's both of them are the answers. What about the second one? All right, for the second one, we have to actually try to make, all right, so for sine of x, we bring that negative 1 to the right side, we'll get 1. And therefore, I'll try to find the sine of x. This one will get 1 over 4. All right, other than 0, 1, negative 1, so we cannot use this, right? So what should you do is actually you need to find the basic angle. So you can actually press your calculator to find the basic angle, right? So this is actually given by sine inverse of x, which is, all right, let me just, let's say I call that basic angle as theta, all right? So theta is sine inverse, sorry, not sine inverse of x, right? So this one is actually theta, all right? Sine inverse of this 1 over 4. If it is negative, so you just take the positive part only. Right, when you take the sine inverse, so make sure your calculator, if it is in degrees, then you set your calculator in degrees. So sine inverse of 1 over 4, right? Sine inverse of 1 over 4. That one will give me actually, all right, theta is actually, all right, this is my basic angle, 14.48 degrees. 14.48 degrees is my basic angle. So let's just recall the acousticity just now, right? So where is sine positive? So ASTC. So we know that the, right, since this sine is actually positive, so we see the part where sine is positive. So of course on these two quadrants, right? For these both of these quadrants. Therefore, where will my basic angle will be? It will be somewhere around here. All right, so this is my 14.48 and my basic angle is another one, which is 14.48 degrees. All right, so for the answer of x in this case, all right, so x will be, all right, so you should start with from, all right, so let me just extend this one. Right, so from the first quadrant, right, so this is my first solution for the value of x, right? You'll see the pattern later. Right, so, all right, so you get 14.48 degrees. Another one for the value of x is from this one to this angle. So how do I find this angle? It's actually something like this, right? This one is 14.48 degrees. So this is my x. So of course, to get the value of x, 180 degrees minus 14.48 degrees. All right, therefore, we solve this one. We get two values, 14.48 degrees. Another one will be 180 minus 14.48 will give me 165.52 degrees. So we got 4 answers for the solutions for this one. So the answers can be collected together. All right, so maybe you can say, all right, therefore, all right, x will be 14.48 degrees. Another one, a comma, all right, 90 degrees, and then I'll have 165.52 degrees. Another one is actually 270 degrees. So this is how you solve the trigonometric equations. Right, so I hope you get the idea, right? So about the basic angle, what does it mean by the basic angle? Right, let's look at the second one. All right, suppose we have this one. All right, so we are given with 2 cos square of x minus 7 cos of x plus with 3 equal to 0. All right, so let's just, we see that this can be transformed into a quadratic equation. So let me just write let m, which is equal to cos of x. Therefore, I'll have my equation will be 2m squared minus 7 of m plus with 3, which is actually equal to 0. To factorize this one, maybe you can use your calculator or you can factorize manually. But in this case, right, suppose I have this one. So this can be factorized as m minus 3, another one which is actually 2m minus 1, right? Which is equal to 0. Therefore, I have m which is equal to 3, another one which is actually m equal to half. Therefore, I need to transform my cos of x. Cos of x will be, because m is actually, we already set this m to be cos of x, therefore we transform this m to be cos of x to be 3. Another one, cos of x, which is actually half. Alright, so now we need to solve this one. Do we have the solution for this one? We don't have. Why? Alright, so let's just look at this. We know that for the cos of x, right, the graph would be something like this. The highest value will be 1 and the smallest will be negative 1. So it will never be 3, right? At any point, at no points of this cos of x, the value of the function will be 3. Therefore, we don't have a solution for this one. So no solution for this one. Right? Easy. Next one, for the cos of x, which is actually equal to half. So what should we do first? We need to find the basic angle. Let me just label my basic angle as theta. Therefore, my basic angle will be cos inverse of half. Bear in mind that if it is negative, so you just need a positive part here. But now in this case, it is actually a positive number. So let's just forget about that negative number. All right. So pressing your calculator, maybe you can find the cos inverse of half would be actually 60 degrees. Therefore, my theta will be 60 degrees. Hence, you need to plot on this acoustic. Let's just recall the ASTC. All right, ASTC. Please take note that my cos is actually positive or negative. It is actually a positive number. Therefore, in this case, where is cos positive? So for the first quadrant, this is my theta. And for the second one, which is cos, which is positive, so C. So in this case, is that basic angle. So this is my basic angle, 60 and 60. What about the solution for this? All right, so we need to find the value of x. So how to find the value of x? So we'll start from this to this. So this is the first one. So we get 60 degrees. For the second one, it should start from this first and until this one. So what is the value of that angle? So you just need to imagine, suppose you start from, all right, so this is 60. So how to get the value of x here? Because one complete cycle will be 360 degrees. Therefore, to get the value of x, 360, we need to subtract 60 in this case. Therefore, I've got x, which is actually equal to 60 degrees and 300 degrees. Are we done? Please take note of this domain of x. The question asks us to find the value of x so that it satisfies these inequalities from 0 until 550. All right, how to get that value? All right, so you just need to imagine. All right, so this is actually 60 degrees. All right, if you go one complete cycle of this 60 degrees, all right, something like this. All right, okay, so this is another angle of x actually. So we have to find the 360, one complete cycle, you just need to plus that 60 degrees. All right, so I'll get 420 degrees. Are we done? All right, let's look at this one. All right, so suppose I need to get the value of x in this case. So I'll get this one, right? One complete cycle. Right, let me just use another color. I've got this one complete cycle. All right, I've got this one as one complete cycle, and then I need to rotate it again. All right, so that I go to this. Therefore, it is actually 360 plus with that 300. All right, okay. All right. So that one will give me actually 660 degrees, but is it in this range? It is out of this range, therefore we should not write the solution. So this one is not involved with the solution. So we just need to have to write these three solutions in this case. Why I need to rotate, make one rotation to add another rotation? Because this is the given question whereby you need to find the value of x, which is between 0 until 540 degrees. All right. If the question asks you to find an up to 360 degrees, then you can stop here. This part is not needed. All right. But now it's different. Okay. I hope you get the idea. Right. So let's look at this one. For this case, all right, you actually need to modify a little bit of the questions where you have to, what we call, use the identities of the trigonometric, where you have the secant square of theta. All right, so let's just say, all right, so let me just simplify this first. All right, 9 tangent theta plus tangent square theta, which is equal to 5, right? Secant square, all right, so you need to change it in terms of tangent. So let's just recall that the secant square is actually, right, secant square theta is actually given by 1 plus tangent square theta. All right, okay, so minus 3. All right, so we need to simplify this one. 9 tangent theta plus with tangent square theta, which is equal to 5 plus 5 tangent square theta minus 3. We need to simplify this. Suppose I bring everything to the left side, therefore I have 9 tangent theta plus tangent square theta minus 5 tangent square theta plus with 3, which is actually equal to 0. I need to simplify this one. So tangent square theta minus 5 tangent square theta will give me negative 4 tangent square theta. And then I have that 9 tangent theta plus 9 tangent theta, negative 5 plus with 3. I've got that one as negative 2, which is actually equal to 0. Make it positive, therefore I have 4 tangent square theta minus 9 tangent theta plus 2, which is actually equal to 0. All right. Okay. Next, I need to transform this. All right. I need to let m, which is actually equal to tangent theta. Therefore, I have 4m squared minus 9m plus with 2, which is actually equal to 0. And then we have to factorize this, what do we call, quadratic equation, so that we get the solution of the function of this equation. So I can factorize this as m minus 2. Another one is actually 4m minus 1. All right, 4m minus 1. Therefore, I can solve this one as m equal to 2. Another one which is actually equal to m equal to 1 over 4. Then I can write that tangent theta, which is actually equal to 2. Another one, of course, m go back to tangent theta, which is actually equal to 1 over 4. All right. Okay, so we need to solve this one. Do we have tangent theta which is equal to 2? So let's just press your calculator. You take tangent inverse of 2. All right, you get a value there. All right, for the tangent of theta, you have tangent theta which is actually equal to 2. Right, so I need to solve for the first one. I have tangent theta which is actually equal to 2. So let's just look at this, your basic angle. So how to find your basic angle? Suppose I take basic angle as alpha. So I get it as a tangent inverse of 2. So the answer is actually 63.43 degrees. All right, 63.43 degrees. That is your basic angle. So ASTC, in this case, tangent is positive. So where is tangent positive? So on this quadrant, 63.43. And another one, tangent is positive on this side. So 63.43 will be here. This is the basic angle. Therefore, to find the value for the theta, right? So in this case, theta will be, the first one is this one. So 63.43 degrees. Another one will be from this to this one. Therefore, I'll get that one as 180 degrees plus with 63.43 degrees. Hence, I'll have 63.43 degrees. Another one would be, just need to add this, 243.43 degrees. All right, you get two values there. Is it within the range? Yes, they are within the range. So that's the first solution. Let's look at the second one, which is tangent theta. All right, I have tangent theta, which is actually equal to 1 over 4. Therefore, I need to find the basic angle. So I have to find the tangent inverse of 1 over 4. All right. So I'll get tangent inverse of 1 over 4 as, all right, 14.04 degrees. So I have 14.04 degrees. So again, that ASTC is much, what do we call, helpful tool for us, right? So ASTC, so my basic angle would be here and also here. 14.04, and what do we call this one is 14.04. So the first solution for the theta in this case is actually 14.04 degrees, which is from this to this one. The second one is from this to this, therefore we'll need to add 180 plus with 14.04 degrees. Therefore, I've got two values of the theta, 14.04 degrees. Another one will be 194.04. All right, 0.04 degrees. So now I have two values of theta, four values of theta. The first one, the second one, the third one, and the fourth one. All right, so we are done with the solution for this problem. All right, and all of them are within the range. All right. All right. So I'm just left with one thing that I'm going to describe. All right. So let's see this one. We have another one. All right. So actually we have cos square of theta. So we know that cos square of theta plus sine square of theta using the identity will be equal to 1. So of course we have cos square of theta will be 1 minus sine square of theta. So we have to change this cos square of theta, right? So that we can write a quadratic equation in terms of sine theta, right? So we'll have this one as 1 minus sine square of theta. All right. So that on the right side, I'm going to expand. I have 6 sine theta plus 6. All right. So I have 4 minus 4 sine square theta. All right. I'm going to bring everything on the right to the left side. Therefore, I have minus 6 sine theta minus 6, which is actually equal to 0. All right. So I need to simplify this one. Negative 4 sine squared theta minus 6 sine theta. So 4 minus 8 will be a negative 2, which is equal to 0. So I have 4 sine squared theta plus with 3 sine, sorry, that one is 6. Plus with 6 sine of theta plus with 2, which is actually equal to 0. I can actually divide each term with 2. Therefore, I have 2 sine squared theta plus with 3 sine theta plus with 1. Right? I divide everything with 2. Right? You divide with 2. All right. Now, you just need to press your calculator. All right? To factorize this one. All right. So, I'll have the first one will be 2 sine theta plus 1. Another one will be a sine theta plus 1 equal to 0. All right. All right. So what will happen? So I'll get this sine theta, which is actually equal to negative half. This one is actually sine theta, which is actually negative 1. So we need to solve this trigonometric equation. So how to solve it? Right. So for this part, never mind. Let's just consider this part first. All right. this one. All right. So to solve this one, of course, you don't have to find the basic angle so on. You just need to recall the graph for the sine of x. So the graph for the sine of x will be something like this. So you want for 1 and -1. So you need to find the value of theta where which makes the sine of theta, which is actually -1. Therefore, it's actually here, which is 270 degrees. Therefore, you get a solution for this one. All right. So for this one, its solution, which is theta, which is actually given by 270 degrees. We are done with this one. The next thing we need to solve is this one. All right. So how to solve that? All right. So let me just write sine theta, which is actually a -1/2. Right. Therefore, we need to find the basic angle. Again, I just need to remind you, to find the basic angle, sine inverse, you don't take that negative part. You just ignore this negative. You just take the number there, which is half. All right. Sine inverse of half will give me actually, all right, 30 degrees. So this is sine inverse, this is my basic angle, which is 30 degrees. So the next step, always after finding your basic angle, you have to plot on this acoustic graph. Right, so ASTC, we want the solution where the sine of theta is actually a negative. On this part, sine is positive, so we want the part where sine is negative. So of course, on this part. All right, so we get the basic angle, which is here 30, and the basic angle, another one, which is here 30. So where is the solution for the first one? All right, to find the value of theta. Right, the solution start from this to go to this one. Right, so 180 plus with 30. Another one from this to go to this. All right, so of course 360. You need to minus 30 degrees. Therefore, the value for the theta is actually 210. Another one is actually 330 degrees. So now you already have 3 solutions. Theta, which is 270, 210, and actually 330. And all of them are within this range. So bear in mind that to find the basic angle for the part where sine theta, which is negative, or cos theta, which is negative, so you just need to take the positive part here, and then you get a basic angle, and you need to find on this ASTC where is the, all right, if the question give you sine, so where is the sine is negative, so of course here. Where is the sine, which where is the cos, which is negative, so of course cos negative is here. And where is the tangent, which is a negative, so of course it's there. All right, something like this. So basically that's the idea. All right, so I think I have completed everything on this what do we call topic. Maybe in the next one we'll look at this solution where we need to solve for the, like for example, we have tangent, right, or sorry, never mind, cos 2 theta, which is actually equal to 60. So how about the basic angle? All right, so we'll see in the next video. See you next. All right, thank you for watching this video.